Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video, and today talking about oxymercuration-demercuration, a fundamental problem in organic chemistry, one that you're more than likely going to see on exams, so you may as well learn it. You may as well learn how to do it right and move forward, do well in organic chemistry. Before that, let me ask you one favor. Please subscribe to my YouTube channel and slap that like button. Leave a comment down below. Engaging with my content is the single best thing you can do for me as a YouTube creator to help me promote my channel and get my methods of doing chemistry out there to the masses. So if you could please slap that like button, slap it again, subscribe to my channel, and leave a comment down below and share my content with your family and friends. It's very helpful to me as a creator. Let's get into this. All right, so the first step in oxymercuration-demercuration is to relax and calm down and to remember it looks just like chlorination. It looks very, very similar to chlorination. Adding Cl2 across a double bond or adding Cl2 and water on a double bond, it's just like that. Slightly different, but you're going to see some substantial similarities. Watch what I'm going to do. So starting with our friend, the pi bond, we are going to feed it mercury. And let's make mercury red. So here's mercury acetate. This first step in this reaction is the pi bond will attack the mercury. Acetate leaves. But remember that in the chlorine reaction, we had the pi bond attack the chlorine, the other chlorine leaves as chloride. But the original chlorine, the first chlorine, the chlorine being attacked, a lone pair from it, that chlorine, formed a bond to the carbon. Same thing is going to happen here. Just like that. Now, this bears extraordinarily strong resemblance to chlorination. If you go back and look at your notes in chlorination, you're going to see essentially the same steps. Only instead of mercury and acetates, it's chlorine. But you're going to see the same arrows. Pattern recognition. You can do it. Okay, now that's going to give us there we go. And of course there's going to be acetate out there as well. Okay, now at this point our friend water will come in and attack here. And you'll get the protonated alcohol, which of course will be deprotonated by additional water. To give you the alcohol. Now we're not quite done. If you look over the arrow, you'll see there's a two-step process here. We're working out the mechanism for the first step right now. We have to do some more work here in a minute. Not much more though, so you're almost done. Students always want to know when they're done. Or when they're almost done. There we go. Now the next step is adding the sodium borohydride. Now that mechanism is not part of this class. So lucky for you, you don't have to know it. All you have to know is that between here and here, we add sodium borohydride, and the mercury comes off. And a mechanism that you don't have to understand at this point. Now, if you take advanced organic chemistry, that's when we start talking about mechanisms like that. All right, guys, so if you found this video helpful, please go ahead and slap that like button, leave a comment down below, and subscribe to my channel. Share my content with your family and friends. It really is helpful to me as a YouTube creator trying to grow my channel. Now, with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.